Okay, this is the last video for our Chapter 4 test review. I'm going to start here with number 26. All right, the first thing I notice when I write this problem down is that it has subtraction. And I'm going to have to condense the logs first. And when I see a subtraction of 2 logs, I can put that in as division of the argument. So log of 2 plus x over x minus 2 equals the log of 5. From here, I can drop the logarithms on each side. That's using a one-to-one property. I can multiply both sides by x minus 2. And then I'm just going to go and solve for x. And x shows up to be 3. I'm going to remember to go back and check. 3 plus 2 is positive and 3 minus 2 is positive, so I will take 3 as my answer. Number 27. I'm going to put that one over here. Find the number of years for $5,300 to grow to $14,100 at 6% compounded semi-annually. So I want to end up with 14,100. I'm investing 5,300. I'm doing it at 6%. Semi-annually is going to be accrued twice a year. And then in t. We don't know our time, so we're going to have to solve for t. What we want to do first is figure out how to get the exponential piece, the base and the exponent, isolated. And the way we're going to do that is by dividing 14,100 by 5,300. Now, I'm going to put that in my calculator just to see what it is. And that comes out to a decimal that is kind of long, so I'm just going to leave it as 14,100 over 5,300. There's no sense in doing extra rounding at the beginning of your problem, so that will make you lose accuracy in your answer if you round too early. Now the 0.06 divided by 2 is 0.03, so I think that's fair game for condensing that down. In order to get this exponent to come down to the front, I have to do a log or a natural log on both sides of the equation. I just prefer to stick with natural log on these. Doesn't matter which one I use. But okay, then I'm going to bring down that exponent to the front. And then I just need to solve for time. So I'm going to accomplish that by dividing by 2 times the ln of 1.03. Then, of course, when this goes in my calculator, I'm going to have to be real careful and get all those parentheses in there, just like I'm supposed to have. So. And you're getting roughly 16.6 years. Time is typically rounded to 1 decimal place. Number 28, a sample of 250 grams of a radioactive substance decays according to this function, where t is the time in years. How much of the substance will be left after 30 years? So you're just finding a of 30. And so that goes straight into your calculator. Again, you guys are going to have to watch and get parentheses in there like you need. And that's roughly 90 grams. All right. Number 29. How long will it take a sample of radioactive substance to decay to half its original amount? So they're talking about half-life here. So this is the equation they're giving you. Now, if it's going to decay to half of its amount, it doesn't matter that you started with 450. We're going to end up with half of it, so that's 225. But again, that doesn't matter. What you need to do here is just realize that if it's decaying to half, this is going to be 1/2. Again, that's taking 225 divided by the 450. For half-life, though, I tend to just totally skip that step, and I go straight to that equation. All right, I just need to find the time, so I'm going to do the ln on each side. When I bring the exponent down to the front, I have the ln of e there, but that's 1, so I don't have to worry about it. And then it's just straight calculator work from here. So the ln of 0.5 divided by negative 0.216 is about 3.21 years. Now in this one, they said to round to the nearest hundredth. And finally, number 30. Assume the cost of a gallon of milk is $2.50. Continuous compounding. Find the time it will take the cost to be twice as much. So we're going to double the price. So I'm going to compare that to the last problem we did. In the last problem, we were doing half of the substance. Now we're doubling. So if I start with this equation and we double, that constant's going to go right to 2. And that's the same as using $5 here. Okay. And now we're going to take the natural log on both sides. Oops, I have forgotten to put in my interest rate, my inflation rate of 0.06. Let me do that real quick. Again, I'm going to be bringing that exponent down to the front. ln of e is 1, so ln of 2 divided by 0.06. Straight into my calculator. And that's roughly 11.6 years. So this one says to the nearest tenth of a year. So as far as rounding goes, if they don't tell you how to round, if it's time, it's typically 1 year. Watch the directions. Sometimes they will tell you within the directions how to round. So there you go. I hope this helps. Please reach out to me if you have any questions.